manufacturing sector. He represents a private institution based in Roopnagar district.
अपने को ले जाने में ना हालत टाइट हो जाएगी, सीढ़ी से ये नहीं हटेगा तो। हाँ ये तो है। हाँ तो मैं देखता हूँ कोई मिल जाता है ना, ये आ जाए इससे बात कर ले। हाँ 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 वो तो कोई दिक्कत नहीं हो, तो मैं देखता हूँ कोई मिल जाएगा तो तरफ रखने वाला। किस तरफ आएगा।
Today, he will be sharing his expertise on the topic CNG engine, focusing on their design, performance, and relevance in sustainable automotive technology. We are honored to have with him with us for this FDP session.
Hello, is my voice audible?
Yes, sir, you are audible.
Yeah. Hello, good evening, everyone.
Good evening, sir.
My name is Gurjeet Singh, and I'm from Ropar, Punjab. I'm working in SML Mahindra Limited, formerly SML Isuzu, in production department from last 20 years. So the topic that today we will share and study will be use of CNG gas in combustible engine. 1 minute. Is the slide visible?
Yes, sir.
Yeah, sure. Thank you. So as we will study use of compressed natural gas in internal combustion engine. So that's what's about today's topic. This is our agenda of today's topic. Introduction, first of all, we will do introduction and objectives, natural gas fundamentals, then CNG properties and characteristics. Then we will study about fuel system components, engine technology and conversions, combustion and performance, environmental benefits. We will study about economics and market trends, safety standards, future outlooks, and key takeaway. So as we all know, it is well known that fossil fuels reserves all over the world are diminishing at an alarming rate, and a shortage of crude oil is expected at the early decades of this century, moreover, probably in this century. So, it is believed that crude oil and petroleum products will become very scarce and costly to find and produce. So, we'll require an alternate source to for transportation and for fulfilling energy demands. So, natural gas, electric, and biofuels and hydrogen vehicles are the alternate source that we can use instead of oil products. So, as rising energy demand, we had to search an alternate source. For that, our topic will be natural gas and CNG. So, air quality and climate targets. What are global energy scenario? As in 2027, the government has switched to Euro 7, so which will drastic cuts in nitrogen oxide, PM, and CO2 conventional fuels facing increasing compliance cost. So for first of all, one is energy demand, rising energy demand. We have to search for alternative source. For air quality and climate targets, we have to search for new alternative sources. So gaseous fuel as bridge, natural gas offers an immediate scale pathway to decarbonization, with while electrification infrastructure matters. So segment fitment ideal for high mileage. Natural gases are ideal for high mileage fleet, refuse trucks, and regional hauls logistics where battery electric vehicle range is limited. So what is CNG and why it's matter? What is CNG? Definition is compressed natural gas stored under pressure in hard containers. It remains in gaseous states, unlike LNG, which is liquid. Key properties: its composition is mostly methane. 92% is methane in CNG gas. Pressure is around 300 to 3600 psi, which is equal to 200 to 250 bar. Rating high octane. Energy density lower volumetric energy density than liquid fuels, requiring large storage tanks to achieve comparable range. So it has a low volumetric energy density than liquid fuels. So it's required large storage tanks. And why it's matter? Environmental impact: significantly lower tailpipe pollutants. It's it is low pollutant vehicles, CNG gases, as compared to diesel, up to 20% lower GHG emissions with near zero potential using RNG. Economically advantage: attractive total cost of ownership for mileage fleets. Fuel costs are typically 30 to 50% lower than gasoline, diesel with stable pricing. Mature technology, proven internal combustion engine technology, establishing refueling infrastructure in many regions and explaining global adoption. So these are the objectives explaining that we will study now. Explain CNG fundamentals in which we will understand properties, storage, and combustion characteristics. Then later on we will study comparative analysis, evaluate performance, emissions, and cost versus gasoline and diesel. System components and safety, detailed fueling system, conversion technology, and safety standards. Then we'll go to market trends, review global market adoption and infrastructure development. And in last, we will discuss about future directions, outline RNG potentials, advanced tanks, and digital integrations. So, with starting with natural gas fundamentals. What are the natural gas composition, its sources? Composition, as I told you earlier, it contains 92% of methane gas in CNG, with small amount of butane 1%, propane 2%, and ethane 4%. So minor amounts of ethane, propane, butane, and traces of nitrogen and carbon dioxide. Fossil sources extracted from conventional gas reservoirs, unconventional shade formations, hydraulic fracturing, and as associated gas from oil wells. From where we get CNG gas, we are getting it from gas reservoirs, conventional shale formations, and from oil wells. Renewable natural gas (RNG). This is one of the gas like CNG only, which we get from bio organic waste, landfill waste, wastewater treatment plants, and livestock anaerobic digesters. Then next, where from we get the CNG gas is from pipeline quality standard. Raw gas undergoes processing to remove water, sulfur, and heavy hydrocarbons to meet strict purity standards for vehicle use. So the last option is pipeline, directly from pipelines. Types of natural gas. Comparison of natural gas sources and their implications for vehicle use and emissions. So first of all, first type of gas is conventional, from where we get extract from traditional porous reservoirs, sandstones, and limestones. Then how can we process them? Standard treatments to remove water, impurities, and heavier hydrocarbons. In which vehicles we can use? We can use it for all vehicle classes. Emissions, what it emits, fossils baseline 20% lower tailpipe कार्बन डाइऑक्साइड वर्सेस डीजल, मतलब इट ये 20% लोअर पोल्यूटेड है डीजल और गैसोलाइन से. Second source is shale tight extracted from low permeability rocks formations requiring fracturing. ये गैस होती है जैसे एक तो निकलती है स्टैंडस्टोन और लाइमस्टोन में जहां से गैस बनती है, एक होती है शेलाइट्स, ये होते हैं ग्राउंड्स के बीच में जो होल्स टाइप होते हैं जिनके बीच में मीथेन जो होती है वो फंस जाती है. नाउडेज इट इज यूज्ड इन अमेरिका टू डेवलप टू एक्सट्रैक्ट दिस गैस. सेम प्रोसेसिंग है इसका, सिमिलर टू कन्वेंशनल बट मे रिक्वायर एडिशनल सेपरेशन स्टेप्स. ऑल व्हीकल्स सीएनजी और लिक्विफाइड यूज इन ऑल व्हीकल्स. Emissions भी सेम है, combustion profile to conventional. Biogas and RNG. Biogas is called RNG, renewable natural gas, captured from organic waste, streams, landfills, wastewater, agriculture, etc. Processing requires cleaning and upgrading to remove CO2 and H2S to pipeline quality. Vehicle use, drop-in dismiss for fossil fuels gas, fully compatible with existing CNG and LNG. It means it can be used for all vehicle classes, and its carbon negative potential is very less. So it is a very clean gas. Global reserves and supply landscapes. Proven natural gas reserve by region. Where are the global reserves and supply landscapes in all over the world? So South and Central America covers around 7.8 trillion cubic meters of natural gas, whereas Europe reserves 3.2, Africa 12.9, North America 15.2, Asia Pacific 16.7, Russia and Central Asia 56.6, and Middle East in major quantities 75.8 trillion cubic meter reserves. Unconventional growth. Shale and tight gas have revolutionized supply particularly in North America, using importers into exporters and stabilizing long-term prices. So RNG potential, biomethane from waste streams, landfills, agriculture is rapidly expanding, offering a carbon neutral or negative fuel source that use existing infrastructure. Supply security, diverse global distribution of reserves compared to oil reduces geopolitical risk, domestic production capabilities, enhance energy independence for many nations. CNG versus LNG for vehicles. Then what is CNG? Is compressed natural gas stored as a gas at ambient temperature under high pressure. Its pressure is around 3600 psi, maximum pressure of 250 according proportionate to 250 bar. Stored at gas at ambient temperature. Ambient, what is ambient temperature? Ambient temperature is neither hot nor cold. It can be a normal temperature, but it has a high pressure. Ideal application best suited for vehicles that return to base or operator regionally. ये उन व्हीकल्स के लिए है जो छोटे किलोमीटर्स के लिए, लाइक स्कूल बसेस, सिटी बसेस, लाइट ड्यूटी व्हीकल्स, अर्बन डिलीवरी व्हीकल्स कि जो 40 किलोमीटर्स टू 50 किलोमीटर्स लो रेंज है जिनकी, वो जाके वापस अपने आ सकते हैं. दैट फॉर दैट वी कैन यूज सीएनजी कंप्रेस्ड नेचुरल गैस सिलेंडर्स. Infrastructure, lower capital expenditure for fueling station compared to LNG. Now, what is LNG? Liquefied natural gas. Stored as a liquid at cryogenic temperature, higher energy density. Its pressure is 20 to 150 psi. So it has a low pressure, but it has a high temperature, 162 degree Celsius. It means it has to be designed for long range transport where fuel capacity is critical. So higher complexity and cost due to cryogenic handling requirements. So it has a higher temperature, so it has to be handled very carefully. Now we will study CNG properties and characteristics. Physical and chemical properties. Physical properties, sensory properties. Naturally colorless and odorless. CNG doesn't have any color or any smell. Disinfectant sulfur has been added for safety and leak detection purposes. Chemical composition mainly contain methane, contain negligible sulfur and zero heavy metals, preventing engine corrosion and catalyst poisoning. Narrow flammability range, high autoignition temperature, and a narrow inflammability temperature makes CNG internally safer than petrol vapors, gasoline vapors. Clean gaseous premix, gas stat ensures superior air mixing, virtually eliminating soot, unburned carbons, and particulate formation. So it is a clean gas which emits low pollution and low gases. So properties, typical natural gas, same, methane 92% and ethane 3.5%. Octane and combustion characteristics. Higher compression ratio. The high octane rating allows engine to operate at high compression ratio without pre-ignition, directly improving thermal efficiency and power output compared to standard gasoline engines. So higher the octane rating, higher the compression ratio. If the compression ratio, octane ratio is high, there will be a knock resistance, low knock resistance, superior resistance to engine knock, permits more advanced ignition timing strategies. This is crucial for maintaining performance under heavy loads, especially in turbocharge application. So the octane ratio of CNG is maximum like 110 to 130 against diesel and gasoline engines. Lean burn potential, CNG wide inflammability limits enable stable lean burn combustion strategies. This significantly reduces pumping losses and improves fuel economy while lowering peak combustion temperature and nitrous oxide conformation. So it is a flammable limity combustion strategies are so good that the fuel burn properly, and so it lowers the peak combustion temperatures. So energy density comparison comparing energy content and storage implication from primary vehicle fuels. First type is energy by mass. High specific energy means less fuel weight for the same energy. Mean you have to less fuel but same energy, high specific energy. So see in CNG, methane has the highest energy by mass. Gasoline has less and diesel has almost less. Energy by volume, Lower volumetric density requires large storage tank, but its drawback is that it has a lower energy by volume, 9 mg. So gasoline has 30 to 34, diesel has 36 to 38 maximum. Storage note, lower tank to tank range. So due to low energy volume, high tanks are required for storage. For gasoline, standard liquid storage assembly, easy handling, established infrastructure convenience. Gasoline is mainly petrol. Diesel, high volumetric density, ideal for long range heavy duty applications. Storage pressure and temperature. Nominal service pressure. Standard vehicles systems operate at 3600 psi, means CNG. Unlike LNG, CNG is stored at an ambient temperature. Ambient means normal temperature, but requires high pressure cylinders to achieve sufficient energy density. Same thermal effects, rapid compression generates significant heat. Gas temperature can rise by 40 degree, more than 40 degrees Celsius during refueling. So cylinders are rated to withstand these thermal cycles without fatigue. Fill density management, dispenser use temperature compensation algorithms. If ambient air is hot, fill pressure is increased. If it's cold, it is decreased to ensure a constant mass of fuel is delivered. So if the temperature is hot, then the pressure will high in the cylinders. If it's cold, then its temperature will be decreased. Fuel quality and specifications. What should be the fuel quality? Calibration consistency. Stable methane number and Warps index are critical for predictable engine mapping, knock resistance, and consistent power delivery across region. So calibrated methane should be must for knock resistance and predictable engine mapping. Contaminant limits should be very low. Strict limits on moisture, oil aerosols to prevent injector foulings, and sulfur ensure system durability. Standardization, there are fuel quality parameters, international standards like ISO 15500 family and SAE J1616 for component designs and material compatibility. So typical CNG fuel specification: methane minimum 75 to 80% must be required. Water content should be less than 10 IBS. Sulfur content should be less than 10 ppm. Oil content should be 0.1 ppmw, and particulate size should be less than 5 microns. Now we will study CNG fuel system components. This is the diagram for a CNG fuel system architecture. First of all, we have a storage cylinder in which CNG gas has been stored at high pressure around 3600 psi. Shut-off valves, manual and solenoid safety isolation valves are there. Then pressure regulators. The main part is of pressure regulator. What does the pressure regulators do? The pressure regulator has a solenoid valve, shut-off valves to shut off gas supplied to the engines. The CNG stored at high pressure in the cylinder is reduced to just below atmospheric pressure by the unit. The negative pressure is also a safety feature that will not allow gas to pass through when the engine is not running. So you can see under with red high pressure 3600 psi. Then when it passed to shut-off valves in the pressure regulator reduce the pressure to engine specification lower to 100 to 100 psi. Then it goes to fuel injectors where fuel gas injects with the gas and air mixtures. Then engine chamber, spark ignition and power generation are there. CNG cylinder classifications. There are 4 types of cylinders that has been used in the market or in industries. We will study one by one. Comparison of type 1 through type 4 storage technologies for vehicle application. Type 1 is all metal heavy duty construction, all metal steel heavy duty. But in weight it is very heavier. Cost is lowest because it is heaviest. Low construction, so cost is low. Durability is very durable. Typical application in stationary and heavy industrial vehicles, this type of cylinders are used. In type 2 metal liner, the construction is of metal liner plus hoop wrap. Weight is medium to heavy but lighter, 30 to 40% lighter than type 1. Cost is low to medium, moderate increase. Durability good, cost effective, balance. Typical application older fleets, budget retrofits vehicles which we can use these cylinders. Type 3 metal liner plus full composite wrap. They are lighter in weight, 60 to 70% lighter than type 1, but its cost significant increase. Cost is high. Durability, long life, fatigue resistance due to high quality. Typical application transit buses, trucks, in which type 3 cylinders are used. Type 4 polymer linear plus full composite wrap advanced cylinders. They are lighter in weight, 70 to 75% lighter than type 1 cylinders. Cost is high, premium material, so cost is also high. Durability, longest life, non-corrosive liner, and they are used in passenger cars and modern fleets. Pressure regulation and control. Same as we have studied before. CNG tank pressure under 3600 psi. Then there are safety valves, high pressure lines, stainless steels. Then pressure regulators, which regulates the pressure to 3600 psi to 100 to 150 psi. Then coalescing filter, low pressure injector rails. Two-stage regulations, reduce tank pressure from 3600 psi to engine rail pressure 120 psi in two steps to ensure constant flow regardless of tank level. Integrated safety, pressure relief device and excess flow valves automatically vent or shut off gas during overpressure, even or line ruptures. That is the function of safety valves. Thermal compensation, engine coolant circulates through the regulator body to counteract the freezing effect caused by rapid gas expansion. Fuel injection system for CNG. What is There is two engines, port injection engines and direct injection engines. Let me tell you something about port injection. Port injection are the engines in which fuel is sprayed in the intake valve, mixing with air before entering the cylinder. So this is a technology, highly proven technology, widely used in dedicated and biofuel conversions. Simple integration into existing manifold designs. It is cost effective, lower system cost due to low pressure requirements, and less complex injector designs. Its performance characteristics: excellent air fuel nominally, power slightly lower, peak power due to volumetric efficiency loss. So they are reliable, keep valves clean, but not so much efficient. Direct engines. Direct engines are those engines in which fuel is sprayed during inside the combustion chamber at very high temperature, sorry, pressure. So it generate high power density, potential comparable to liquid fuels, injecting gas after intact valve cross, recover volumetric efficiency, advanced control, precise combustion facing and stratification capabilities, enables high compression ratio without knocking limitations. Complexity and cost. More complex injectors need to handle high in cylinder pressure, requires high pressure regulation and sophisticated issue strategies. So its cost is high. ECM sensors and diagnostic. As we had studied before in direct injection engines, in this technology is used ECM sensors and diagnostic. So what is ECM? Electronic control module. In the ECM, we can call ECM as a heart of the CNG engine, which dynamically manage the air fuel ratio, spark timings, and exhaust gas regulation to optimize combustion efficiency for methane specific properties. Real-time monitoring. It also monitored regularly, continuously tracks critical parameters, including fuel rail pressure, manifold temperature, knock events, and exhaust O2 levels to ensure safe and efficient operations. Onboard diagnostic. ECM function is to integrate diagnostic systems, monitor emissions compliance, detect system faults, and facilitate rapid troubleshootings through standard DTC protocols. So, what are the hardware components that are used in CNG engines? High pressure tubing and fittings. The tubes which are used in CNG are of stainless steel or approved material rated for system pressure rigid mounting required. Shut-off valves, manual service valves for maintenance and automatic solenoids for key off isolations. Check-up valves, prevent backflow during refueling, and ensure directional flow through the system. Fuel filtration, coalescing filter trap oil aerosols and particulates to protect sensitive injectors. Refueling receptacle, NGV1 or NGV2 standard compatible profile masking dispenser nozzle for safe filling. So now engine technology and conversion. So here we have two types of engine, dedicated CNG engines and converted engines. We will study about both dedicated CNG versus converted engines. What are dedicated engines? Dedicated are full OEM integration with vehicle diagnostic and dashboard indicators and compressor manufacturer. Engine optimization. Dedicated engines are those engines which are manufactured from company itself. So engines designed specifically for natural gas with optimized compression ratio to level high octane rating, calibration and performance with precious ECU mapping for optimal ignition timing and air fuel ratio, calibrated for maximum thermal efficiency and lowest emission. So they are dedicated C engines for full factory integration, full OEM integration with vehicle diagnostic, dashboard indicators, and comprehensive manufacturer warranty support. So we get warranty support with diagnostic, all sensors, dashboard indicators from dedicated CNG engines. Converted engines, the vehicles which are on gasolines and or diesels are converted into with CNG kits. Flexibility and retrofit allow existing gasoline or diesel vehicle to be adopted for CNG use. Offers flexible deployment for diverse fleet types. Performance variability. Its performance heavily depend on the conversion kit quality and installation. May not achieve same efficiency gains and dedicated engines as dedicated engines. So because they are conventional kit converted engines, so conversion kit vary from installation and conversion kits. So cost effectiveness, lower upfront capital invest compared to buying new dedicated vehicles, so its cost is low. Biofuel CNG over petrol gasoline petrol systems. Dual tank architecture. Vehicles are equipped with two separate fuel tanks and a driver selectable switch, allowing seamless transition between CNG and gasoline operation. Extended range and flexibility significantly mitigates range anxiety and infrastructure gaps while ensuring the vehicle can operate on gasoline when CNG stations are unavailable. So dual tank architecture biofuel engines are those engines which can run both on petrol plus CNG. So on completion of CNG, they can be run on petrol, which can run up to 900 kilometer, but only with gasoline they can run up to 50 kilometer, and with CNG they can run to 350 kilometer vehicle can. So calibration and compliance requires sophisticated dual map ECU calibration for optimal combustion in both modes and strict adherence to emission compliances. Second one is dual fuel CNG plus diesel systems. Pilot diesel ignition system retains the diesel compression ignition cycles, but inject a small pilot amount of diesel to ignite the air CNG mixture, eliminating the need for spark plugs while maintaining diesel-like torque. So heavy duty, for where CNG diesel engines are used, it for heavy duty and cost benefits. Optimized for high torque, heavy duty applications, achieve significant fuel cost reduction by substituting 50 to 80% of expensive diesel with cheaper CNG while lowering PM and nitrous oxide output. Substitution control logic, advanced ECM dynamically adjust the gas to diesel ratio based on engine load and speed. System actively monitor NOx sensors to prevent detonation and ensure durability. Engine modifications. What are the engine modification that can be done in CNG engines? Higher compression ratio, increased ratio enabled by CNG, higher octane rating for better thermal efficiency. So higher the octane rating, for better, higher will be the thermal efficiency. Ignition system upgrade, higher energy coils and spark plugs seized for lean operation and hard to ignite mixtures. Valve train hardening, specialized valve seats and materials suited for dry fuel combustion without liquid lubrications. after treatment system, optimized three-way catalyst for stoichiometric engines to manage specific CNG emissions. Conversion kits and OEM options, same that we study. Converted kits and OEM options. Storage and mounting. In red, we can see high pressure cylinders secured with heavy duty brackets to withstand crash load. Includes fill respectable with check valves. Fuel delivery, stainless steel high pressure lines route route gas through filters to the regulator, stepping pressure down for the injector rails. Electronic control ECM, dedicated CNG ECM or piggy bank system manage injection timing, monitoring pressures, temperature sensors to ensure optimal air fuel ratio. OEM integration, factory options feature fully integrated dashboards, hardened valve seats, and optimized Suspension for tank weights. Now, overview to combustion and performance. CNG combustion in SI engine. So it is same as we have studied before. Pre-mixed charge, air and fuel mixed homogeneously in tank or cylinder. Then it's got on go in spark ignition, higher energy spark initiates the flame canal development. So blue indicate premix charges and spark ignition. Then as the spark ignite, then it convert into combustion strategy or lean burn. As the combustion go, heat releases and the vehicle moves. Power and expansion. Flame speed and ignition characteristics. Methane flame speed, lower laminar flame speed compared to gasoline, requires high turbulence and optimal mixing quality to ensure complete combustion. Then ignition energy requirements. Methane requires higher ignition energy due to its suitable molecular structure. Strong spark systems are crucial to ignite lean mixture and extend the lean limit. Knock resistance and compression. Higher octane rating provides superior knock resistance capability, enabling advanced spark timing and higher compression ratio for improved thermal efficiency. Performance wise comparison, evaluation of CNG engines characteristics relative to conventional liquid fuels. CNG peak power comparable with optimized engine due to high octane, slight, whereas low and torque slightly lower than diesel requires optimized gearing or turbocharging to match diesel utility. Competitive when optimized. Higher octane allows high compression. Lean burn strategies can exceed gasoline efficiencies. So it is a clean gas. Gasoline or petrol reference baseline, high specific power density and wide RPM range. So it has a high power, peak power. So in around torque, it has a low torque. Typically develop peak torque at a higher RPM compared to diesel. So it has a low torque. Efficiency, baseline efficiency limited by knock at high compression ratios. Whereas diesel lower specific power due to lower engine speed limits and combustion characteristics. But it has a high torque, so it high torque available at very low RPM, ideal for heavy loads. So always our diesel trucks, buses carry heavy loads, so they are high torque. Efficiency, highest thermal efficiency, lowest fuel consumption per cycle due to lean burn and high compression efficiency. Thermal efficiency consideration. Higher octane efficiency gains. CNG high research octane number allow for higher compression ratios than gasoline, directly increasing thermodynamic efficiency limits without any knocking. Advanced combustion cycles, implementation of lean burn strategies and Miller cycles significantly reduce pumping loss at part load, improving specific fuel consumption. Reduce heat losses, optimized combustion facing and lower peak flame temperature in lean burn modes, reduce heat transfer to cylinder walls, retaining more energy for mechanical works. Environmental benefits. So, due to its simpler chemical structure, methane and low carbon to hydrogen ratio, compressed natural gas emits approximate 27% less carbon dioxide than petroleum fuel at the tailpipe. So RNG amplifies reduction. The use of renewable natural gas dramatically increase environmental benefits. Blending RNG can lower life cycle emissions further, potentially achieving carbon negative ratings depending on the feedstock sources. So natural gas engine offer immediate proven carbon reduction for heavy duty application compared to conversion diesel and baseline. So it is around 30 to 17% less polluted than diesel and gasoline engines. So nitrogen and PM emissions near zero NOx performance. Modern natural gas engine achieves around 0.02 NOx using standard three-way catalyst. These meet the strict CARBs near zero optional standard, which are 90% cleaner than current federal limits. Minimum particulate matters, combustion of methane, a simple gaseous hydrocarbon produce virtually no soot. This result in negligible particulate metals emissions compared to complex liquid fuels. Simplified after treatment, spark ignited engines eliminate the need for complex diesel particulate filters and selective catalysts, reduced system requiring diesel exhaust fluids. This is the life cycle emission and methane leakage. Renewable natural gas benefits. Sustainable production source. Product produced from captured biogas at landfills, wastewater treatment plants, and livestock farms by anaerobic digestion, turning waste liabilities into energy assets. So this is the benefit of renewable natural gas. Seamless drop in compatibility. RNG is processed to be chemically identical to fossil natural gas. It requires no changes to existing CNG vehicle engines, storage tank, or refueling infrastructure, so it can be used as it is. Life cycle decarbonization offers significant well-to-well GHG reductions. Some pathways like dairy manure can be carbon negative by preventing methane release into the atmosphere. Small engines and non-rapid road applications, where this non-road applications are those vehicles which are not run on roads like forklifters, power forklifters, ice reefer surfaces, and commercial launch equipments. So equipment and emissions, CNG power forklifters, surfaces, and commercial lawn equipments will drastically reduce hydrocarbons, carbon monoxide, and nitrogen oxide compared to small gasoline engine. Clean and odorless operation eliminates the heavy exhaust smell and soot associated with diesel or older propionate units, improving operator comfort and health during long shifts. So it is odorless and clean gas, which result in comfort and health during long shifts. Confined environment safety, critical for indoor warehouses, factories, and noise sensitive urban zones. Low evaporative emissions means safer indoor storage and reduced ventilation requirement. Economic analysis, fuel cost comparison. This is the natural average retail fuel price. So 40 to 60% cost saving. CNG consistently offers substantial saving over gasoline and diesel, with natural gas price decoupled from oil markets. Fuel expense remain predictably lower per mile. Price stability. Unlike volatile petroleum markets, natural gas commodity prices are historical stable due to abundant domestic supply, allowing for more accurate long-term fleet budgeting. High mileage, the return on investment accelerates with high mileage, high utilization fleets, maximum the benefits of the fuel price differential offsetting initial conversion cost faster. So it is the price index. Gasoline is 3.5 $3.55 price per dollar, and diesel price is around $4.1, whereas CNG's price is $2.15 cheaper than petrol and diesel. TCO drivers, fuels and maintenance saving. It has a lower fuel cost and reduce after treatment system maintenance expense. So the system maintenance is also low. Upfront investment and paybacks. Initial cost of tanks, conversion kits balanced against ROA timeline. Residual value impact, market resale value is higher. Consideration for CNG equipped vehicles. Duty cycle element, matching vehicle utilization pattern to maximize economic benefits. So it is economically very easy. So global market size and growth, around in 2004 it was around 40.7 billion market in the overall world. Now in 2030 34, sorry, it has been to forecast around 27.3 billion. So, what should be the global market size and growth? Emission rules and mandate. Strictly global emission standards like Euro 7 complete compel fleet operators to adopt cleaner alternatives. CNG offers a cost-effective compliance pathway for medium and heavy-duty transport sectors. Renewable natural gas, the scalability of bio-CNG transforms natural gas vehicle into carbon neutral or carbon negative solutions. This significantly boosts the long-term viability and attractiveness of CNG technology for sustainability goals. OEM integration, major vehicle manufacturers are expanding factories fitted CNG options. Integrated system offer better reliability, optimized performance, and warranty coverage compared to aftermarket conversion, driving market and confidence. What are the infrastructure and incentives? So expanding refueling network, over 385 active CNG stations currently operate across the US. Alternatively, fuel corridors are rapidly expanding to connect regional hubs and long haul routes. Financial partnership, public private partnership, and target government grants significantly reduce capital expenditure for new stations, construction, and fleet conversions. Policy support and mandates. Adoption is accelerated by federal alternative fuel tax credits, favorable pricing structure, and emerging clean fleet mandates at a state and municipal levels. What are the safety and standards for CNG versus liquid fuel? CNG safety profile, lighter than air dispersion. Unlike unlike like liquid fuel vapors, CNG has specific gravity of zero point 0.6 ohm. In the event of a leak, it rises and dissipates rapidly into the atmosphere, significantly reducing the potential for ignition in open areas. Narrow flammability range, natural gas require a specific concentration to combust. The narrow range make accidental ignition more difficult compared to the wider volatile limits of gasoline vapors. No liquid spills. Stored as a gas, it has no liquid spills. CNG cannot form liquid puddles. This eliminates soil contamination, risk, and slip hazards commonly associated with diesel or gasoline spills during refueling or accidents. So these are the liquid fuel risks, pooling and spill hazards. Liquid fuels are heavier than air, so spills pool on the ground and can flow into the drains or soil, creating persistent fire hazards and requiring costly environmental cleanup procedures. Vapor accumulation, gasoline vapors are heavier than air and settle in low-lying areas, pits, basements. They can travel along the ground to distant ignition sources, posing a several flashback risk. Lower ignition temperature, gasoline has a very low flash point and can ignite easily, while diesel is safer than gasoline, but both can create liquid residuals that remain flammable for longer periods compared to dissipating gas. These are the code standards and inspection. FMVSS regulations ensures fuel system integrity during impacts, mandate strict containers integrity testing, burst fire cycling, NFPA 52 standards, comprehensive code covering vehicle gaseous fuel system and CNG fueling facility safety requirements, ISO 1500 series, international standards specifying performance and testing for individual CNG fuel system components like valves, regulator, etc., cylinder inspections, mandatory visual inspection for every 36 months or 3600 miles, whichever come first, and immediately after any accident fire, you have to inspect your cylinders. Station safety and best practices. Trained operators and pressure verification ensure personal competence and verify 300 to 300 sorry 3000 to 3600 psi compatibility before filling. So it should trained operator for pressure verification. There should be a trained operator for pressure verification, pre-fill inspection, check nozzle respectable conditions, and listen for leaks. Before filling, you should check nozzles, O-rings, debris, and listen for any leaks, etc. Standard operating procedures. You should have to follow standard operating procedures like strictly follow posted refueling steps, zero tolerance for smoking and open flames. Maintenance and redundancy. Routing station, service station, filters, dryers, and backup planning for uptime. future trends and conclusions. So these are the future outlooks and trends. Bio CNG and RNG scale up. Transition to carbon negative pathways by leveraging renewable natural gas from organic waste and digester. Digital integration, implementation of smart sensors, telematics, and real-time leak detection for enhanced safety and predictive maintenance. Advanced storage technology, adoption of type 4 composite cylinders, and advanced manufacturing to reduce vehicle weight and system cost. As we discussed in type 4, that they are lighter in weight, maintenance, manufacturing to reduce vehicle weight and system cost. OEM and hybrid concepts, expansion of factory fitted CNG options, and development of hybrid CNGs powertrains for optimal efficiency. Key takeaways: cleaner and cost effective. CNG enables significant cleaner IC engine, internal combustion engine operations with near zero nitrogen oxide emissions while delivering operational cost saving. Mature technology backed by proven components, established safety standards, and an expanding global refueling infrastructure. So it is a mature technology. Strong TCU and RNG future offers compelling total cost of ownership for many duty cycles, with carbon negative potential when paired with renewable natural gas energy. So this was the today topic of this about natural. Hello, is my voice audible?
Yes, sir.
Yes, sir, you are audible.
Yeah. Thank you, sir. So this was the today topic of use of natural compressed gas in internal combustion engines. So is it was clear to all?
If
Or any
any
questions?
participant has any question, you may ask, please. Participants can unmute themselves and ask questions. If anyone has any question, please ask.
Ji, sir, good evening.
Good evening, sir.
Sir, actually, I want to ask one question about CNG, dedicated CNG engine.
Hmm.
That, as you told, that CNG is working very fine at higher compression ratio, sir.
Yeah.
Then why we are not able to develop an engine which can work on diesel and CNG? Because diesel has matlab high compression ratio, sir.
Sir, already we are making buses or trucks with diesel plus CNG engines. When I used to work in Mahindra, na, so we used to make three-wheelers, which was used to work on diesel plus CNG.
Okay, sir.
We are already making, but in light vehicles we use petrol with CNG because it has a high compression ratio. एक्चुअली जो हैवी व्हीकल्स होते हैं ना सर, उसमें जैसे ट्रक्स और बसेस होती हैं जो जिनमें हैवी लोड्स होता है, उनके लिए हाई टॉर्क जनरेट चाहिए होता है. इसमें हम डीजल इंजन प्लस सीएनजी यूज करते हैं. जो जैसे कार्स हैं या टू व्हीलर्स भी आए थे, उनमें हम पेट्रोल इंजन यूज करते हैं जस्ट फॉर इग्निशन एंड स्टार्टिंग पर्पसेस.
लेकिन अभी तक सर मार्केट में ऐसा कोई व्हीकल मैंने देखा नहीं है कि जो डीजल और सीएनजी दोनों पे काम कर रहा हो फॉर मतलब
सर
हायर टॉर्क रिक्वायरमेंट, सर.
महिंद्रा का ना महिंद्रा का थ्री व्हीलर आता है. महिंद्रा का थ्री व्हीलर आता है सर.
ओके सर.
हाँ, वो डीजल प्लस सीएनजी पे काम करता है.
तो
लोड कैरियर है
एक्चुअली
वो.
वो बाई फ्यूल इंजन है या ड्यूअल फ्यूल इंजन है, सर?
हाँ जी
वो बाई फ्यूल इंजन है या ड्यूअल फ्यूल इंजन है?
सर, वो बायोफ्यूल इंजन है सर. वो डीआई इंजन नहीं है, वो बायोफ्यूल इंजन है.
नहीं सर, मैं पूछ रहा हूँ वो ड्यूअल फ्यूल इंजन है या बाई फ्यूल इंजन है, सर?
बायोफ्यूल इंजन है सर, बायोफ्यूल इंजन है.
तो मतलब जैसे हम पेट्रोल में हम सीएनजी, पेट्रोल इंजन में सीएनजी और पेट्रोल यूज कर सकते हैं एज ए
हाँ
बायोफ्यूल
जी,
सर, वैसे
हाँ जी,
डीजल
हाँ
में
जी।
हम सीएनजी और डीजल यूज कर सकते हैं सर?
सर डीजल जो होता है वो हाई टॉर्क करने के लिए उसको वो करता है, चलता है वो सीएनजी पे ही है।
ओके सर।
हाँ
तो
जी
उसमें कंबशन कैसे होता है सर फिर?
सर, वो क्या होता है, एयर और जो सीएनजी गैस है इसका एक मिक्सचर होता है, और जो डीजल होता है वो इग्नाइट करने के लिए उसको टॉर्क देने के लिए वो यूज होता है।
मीन्स हम पायलट फ्यूल एज ए डीजल यूज करते हैं सर?
हाँ जी, हाँ जी, हाँ जी सर, बिल्कुल श्योर।
तो
राइट।
वो तो फिर ड्यूअल फ्यूल इंजन हो गया ना सर?
हाँ जी,
वो तो ड्यूअल फ्यूल इंजन हो गया ना, हम दो फ्यूल एक साथ यूज कर रहे हैं, डीजल भी और सीएनजी भी सर।
हाँ जी, हाँ जी।
ओके सर।
रेनबो, पापा को रेनबो बनाना चाहती थी।
एनी मोर
थैंक यू वेरी
क्वेश्चन
मच
सर?
सर। थैंक यू
थैंक यू सर।
फॉर योर इंफॉर्मेटिव सेशन सर, गुरजीत सर।
थैंक यू सर, थैंक यू वेरी मच।
ओके।
ओके सर।
Any
Thank you so much, sir.
any other participant having question? You may ask.
Good evening, sir. Hello.
देखो मेरा हाउस, हाउस, हाउस।
चल झोपर शॉल घे तिथे, शॉल घे, किती शॉल घे, झोप झोप, पहिले झोप तू, मग शाळेत उठत नाही सकाळी. गेलं. एक मिनिट. इथे दुपट्टा. ये काय को लग रहा है तेरे को?
Please unmute yourself. Only those who want to ask questions, they can unmute yourself. Rest all the participants, please mute yourself. Anyone having question? Gurjit sir, are you there? Okay, so thank you all of you for joining this session. We shall join tomorrow at 6 p.m. for the third session. Thank you all for joining.
Thank you, sir.